Question 5 gives us an f of x equation and wants us to determine all the critical values of that equation. So first we got to know what a critical value is. Critical values are the point on a graph where the first derivative equals 0 or the first derivative is undefined, so has no value there. So that's what we're going looking for with this starting off equation f of x. So we've got f of x equals, and then we've got the cube root of x squared minus 8x. Well, if we're going to find where the derivative equals 0 or where the derivative is undefined, guess what? We're going to have to find the actual derivative. So when we go to look at our f of x right now, what we have to do is stop and sort of address the situation and look to see if there are any algebraic rewrites that we might have to look out for. And sure enough, in this problem, we have one of the standard rewrites that you need to be looking out for, which is anytime we've got a root on a problem, some x to some root with some power, you're always going to need to rewrite this as x to the power divided by the root. So if you had something like the cube root of x to the fifth, you'd want to rewrite that as x to the power of 5 over the root of 3. The most common one to see is a square root, which conveniently has an unwritten 1 for the power and an unwritten 2 for the root, so that would be an x to the 1/2 power. So looking at our specific situation here, all of this stuff on the inside, even though it's not written this way, is all to the first power. So this rewrite that we have to do is going to look like x squared minus 8x, all that stuff inside the root, to the power of 1 over the root of 3. So that's our rewrite to get started on this problem. From there, we look at the problem and we have to define what type of rule, chain rule, product rule, quotient rule, we might need to be using. And so as I look at this, the format of this problem looks like it's something raised to a power here. So anytime I have something inside something raised to a power, I use the chain rule. And my chain rule saying is d in times d out. The derivative of the inside piece times the derivative of the outside piece. So whenever I'm doing something like this, I just break it into smaller bite-sized problems and then fill in my little recipe here as it requires me to. So I'll label that chunk my in. So the inside the parentheses piece, x squared minus 8x. And then the outside piece here is going to be all this stuff to the 1/3 power. So my out is really just a bunch of junk to the 1/3 power. Then going to find my d in, that's the derivative of the inside, that's just my little saying for it. The derivative of the inside will do a power rule. I bring this 2 down in front, I get 2x minus, and then this unwritten 1 power here times that 8 gets me 8, and then x to the 0, which we've talked about before, is just going to equal to 1. So my d in is 2x minus 8. My d out is going to be a big power rule. So I'm going to bring this power down. I bring the 1/3 down. I leave all that junk alone inside that parentheses, and then I'm going to subtract 1 from the power. And what that junk is that I have left alone, that's just going to be x squared minus 8x. So I've got all my pieces I need to do my chain rule. I've got my d in, I've got my d out, and now I'm going to bring all that together to give me my f prime of x. So f prime of x is going to equal, first go grab the derivative of the inside. So the d in, which is 2x minus 8, times the derivative of the outside, so the d out, which is going to be 1/3, and then times x squared minus 8x, all to the negative 2/3 power. Now that I have that derivative, the next thing I need to do is determine where that derivative is equal to 0 or where it is undefined. And so to do that, I'm going to go ahead and to find those values when I have a multiple choice math exam in front of me. I'm actually just going to use the answers they've given me and test those values in my derivative. And if my calculator ends up giving me out a 0 or an undefined, which would be a blank out for the y value, then I know that what I'm looking at is a critical value, and I can use that to help me find my right answer. So the process for doing this in our calculator to find those using the answers is we'll take this whole equation, we'll shove this into y1, we'll graph it, And then from there, we'll do a second calc, and then we'll choose number 1 from that calc menu, which is value. And in that situation, so we're going to calc the value at, and whatever the x value is will be one of the answers here. And if the y value comes out as either a 0 or it comes back as a blank, there's nothing in there. So if our answer is 0 or if our answer is blank, then in those situations that tells me that I have a critical value. If y equals anything else, then we know that this is not a critical value. So I'll open up my calculator and I'll shove this equation into my y equals. So y equals, and I'll move it a little bit to the side here so we can kind of read it a little bit easier. So that'll be parentheses 2x minus 8. Close it, and then I've got 1/3, so 1 divided by 3, and then open a parentheses, and x squared minus 8x. Close it, and then we'll raise this, and especially if you have one of the older calculators, whenever you raise something to a power, you need to open a set of parentheses, -2 divided by 3, and then go ahead and close it. So we shoved it into y1. Now we'll graph that equation, and I'll hit second calc, and then number 1 value. And we're just going to start at answer A. So answer A says x equals 0 should be a good answer. So I type in 0, and I hit enter. And the y value came back as a blank. So blank is one of my options. That means it's a critical value. So starting to list my critical values, I know for sure x equals 0 is a critical value because I plugged it into my derivative and it gave me a blank, which meant it was undefined. We'll now go back to the calculator and go through our second calc value process again. So second calc, and then again number 1 value. The other value on answer A was 8. So we'll look and type in 8, and we hit enter. And again, I get out a blank from my y value. So a blank means when I get that out after typing in an x value, that is also a critical value. So I know x equals 8 is also a critical value, which is telling me right now that I know for sure the answer is in C, and I know for sure the answer is in D. So the only possible answer left that could work for us would be answer B, that has x equals 4 is also a critical value. So we'll go check that last value and see if that gives us what we need. So we hit second calc, and then again number 1 value. And this time we want the value of 4, so I type in 4. And that tells me that I have a y value equal to 0. Well, if a y value was equal to 0, that was one of the results that told us we had a critical value. So we also know that x equals 4 is a critical value. That tells us for sure our final answer is option B. So again, the way this process works is critical values happen where we have a derivative equal to 0 or a derivative that is undefined, which in our calculator means a y value that comes back as blank. So we take our derivative, shove that into y1, and then just test answers by calculating the value until we see which ones have 0 or blank, and those are our critical values. List them off and choose your answer.